Okay, so this is the second problem, and we are going to apply the same method we used in solving question 1 on this as well. So in this problem, we have a hydraulic actuator length BC. So this is an hydraulic actuator, all right, and they are saying that it is extending at a constant rate of 0.25 meter per second. That means the slider here, or the shaft here, is sliding or is moving up at this velocity, and you're supposed to determine the angular velocity and angular acceleration of the crane's boom AD when the angle beta is 35 degrees. So I'm looking for the velocity, the angular velocity and angular acceleration of this guy here. All right, so just as the previous, when the link AB is rotating, the velocity C here will be the same velocity if the link AD is rotating. All right, now the C slides relative to what B. Okay, so the velocity given here is a sliding velocity between C and B. So let's model our system into this form, something like this. And you could see also that, so we have A, B, and C. You could see that AC and D are on the same link. So the angular velocity of AC is the same as angular velocity of what? AD. So here is 35. Here is AC. All right. Now we have a sliding velocity 0.25. So first off, we know some parameters of C with respect to B. So we can begin by comparing C to B. It shouldn't be any problem comparing C to A first. So from our general relationship, we say if I have any 2 points A and B, then VA when I'm comparing to B will be VB plus VA with respect to B plus what? Omega AB cross R of A with respect to B. So this time we are going to compare C to B. So VC will be equal to VB plus V of C with respect to B plus omega BC cross R of C with respect to B. What do we know? VB is 0 because that's a fixed point here. All right. And then VC relative B is what is given as what? 0.25. But you're going to act in this direction. But we don't know the angle here to put it in what? Sine and cosine form. So we can create a right angle triangle here. All right. Knowing that from here to here is 3m. Here will be 3 sine 35, and then from here to here will be what? 3 cos 35. All right, that means that from this point to this point is going to be what? 3 cos 35 minus 2. All right, so from A to B is 2. We want from B to the end here, so this will be, so 3 sine 35. This one is 1.71, 1.72, 1.729, and then this will be 3 cos 35 minus 2, 0.4575. 0.4575. So if I'm just taking this part out, I have something like this. I have here and here. There is 1.729, and then here is 0.4575. These are the lengths, right? This is, we use the length to get these values. Okay, so if we want the angle theta here, we can say that tan theta is what? Opposite 1.729 over adjacent 0.4575. So theta will be tan inverse of 1.729 out of 0.4575. Theta gives me tan inverse of 1.729 0.4575. So we have 75.178 degrees. Okay, so the angle here, theta, is the 75. So we can, let's say this here. So the velocity v of c with respect to b is going to be along the same direction, making an angle what? Theta here. So this one will be vc relative b cos theta I, and then vc relative b sine what? Theta g. Okay, so all you are going to say is that from here, I mean, like in solving, because this is explanation, so in writing in your book, we are looking for vc relative b. So if you join this on the diagram and then you find this and this, then you can just find the angle using this and this and put it here. No need to be drawing several of these. I was doing this to make you understand what I'm doing. Now, real quick, knowing that theta is 75, let's get to work. So vc relative b is going to be v. So we are using v to represent the velocity. In fact, the velocity is known, all right, which is 0.25. so vc relative b is equal to 0.25 into brackets cos 75.178 I plus 0.25 sine 75.178 j. And then the angular velocity we don't know, right? So omega bc we don't know, just say omega k. And r of c relative b, so r of c relative b is just a distance from here to here, and then from a distance in the horizontal direction and the vertical, which is what? This and this. So r of c relative b will be equal to 0.4575 I plus 1.729 g. All right, so let's make our substitution. So vc will be equal to 0 plus 0. So this will be 0.25 cos 75.178 I plus 0.25 sine 75.178 j plus omega k cross 0.4575 I plus 1.729 j. All right, so from here you can simplify further. 0.25 cos 75.179 and 78. So vc will be equal to 0.06395 I plus 0.241 or 0.242 j, and then here I'll have plus omega k cross this, so that will be the numbers multiplying number 0.4575 omega k cross I will be j. If you forget to just do ijk, k cross I is j. And then next we have plus omega times 1.729 k cross j is negative what? I. So that would mean VC is equal to 0. So that we are grouping the items. We have 0.06395 minus 1.729 I, and then plus 0.242 plus 0.4575 omega g. All right, then we will go and find velocity of what? C with respect to A. All right, so velocity of C with respect to A, let's get that. So that will be velocity of C is equal to velocity of A plus velocity of C with respect to A plus angular velocity of what? AC cross R of C with respect to what? A. So here VC we don't know, VA is 0, there's no sliding velocity between them. Omega we don't know, so omega AC. So here you see we have two omegas we don't know. All right, so it's better we have a difference. So I'm making this one omega AC to represent the magnitude of the angular velocity. Direction is still k, and then cross R of C relative A is just 3 sine cos 35 and then 3 sine 35. So 3 cos 35 I plus 3 sine 35g. So VC will be equal to, so 3 cos 35, 3 cos 35. That is 2.457. So 2.457 omega AC I. No, so K cross I is J, right? And then 3 sine 35 is 1.729. 1.72. Oh, 1.720. There's a slight mistake here, so you correct that. It's supposed to be 1.720. Okay. So your answer might differ from mine a little bit. All right, very small. So yeah. So we have plus 1.72721 omega AC. K cross J is what? K cross J is negative I, right? Okay. So once again, the velocity here, the VC here is equal to the VC here. All right. So yes, I made a slight mistake here, but if I change this, that would mean I have to change everything. But I think the angle is like 75. All right, so there's going to be a very slight difference, and yeah. So from here, knowing that VC and VC are the same, we can say that 2.457 omega ACJ. All right, let me maintain. No, I can't maintain the mistake. So 0.2457 omega ACJ plus 1.721 omega AC minus 1.721 omega AC I is equal to 0.06395 minus 1.729 I plus 0.242 plus 0.4575 omega G. So here my omega is omega BC, omega AC. I think that one has already been done. So you compare J to J, you compare I to I. So negative 1.721 omega AC is equal to 0.06395 minus we didn't bring the omega here. So when we're grouping the i's, this is an I and this is an I. So here we'll have the omega. So there should be omega here too as well. So 1.729 omega I. So 1.729 omega. And then 2.457 omega AC should be equal to 0.242 plus 0.4575 omega. Okay, so from here we can just group them. We can take those with omega and add to the guys here. So that will mean we have minus 1.721 omega AC plus 1.729. Okay, so that will mean that the term here and the term here should be the same. I record this is the mistake I made up there, so let's just correct that one. Hoping I'll get close. Omega is equal to 0.06395 equation 1, and then 2.457 omega AC minus 0.4575 omega is equal to 0.242 equation 2. Here you see I have already made you aware I made a mistake up there by instead of writing 1.720 I made it 1.729. But I'm realizing that I'm supposed to get the same terms here. All right, so I'm just trying to make it up, just put it into see if we are going to get a more accurate answer. All right, so if you make the correction by not bringing 1.729, you should be fine. And I think it wouldn't even be different. It wouldn't even be that much different. All right, so with these two equations, you saw them simultaneously. We just have to say omega AC x omega y. So I'm getting omega AC to be 0.129 and omega to be 0.166. Yeah, 166. So yes, it should be getting something around this area. All right, so here I already made you aware omega AC is same as what omega AD. Okay, so the angular velocity of the boom omega AD is equal to what? 0.129 rad per second. All right, so we are done with the angular velocity, and the next is what? The angular acceleration. All right, so real quick, the angular acceleration is going to follow the same procedure. So AC will be equal to AB plus AC relative B plus alpha cross R of C relative B plus 2 omega BC cross V of C relative B minus omega squared R of C relative B. AB is 0, AC relative B is 0, because they said this is a translational relative velocity And then the sliding velocity is a constant velocity, so the acceleration is going to be 0. Alpha we don't know, so alpha AC is going to be, let's say, alpha K. And then let's just make it, no, is it A? No, B. So alpha we don't know, so alpha BC is just alpha BC, right? So alpha BCK. And then R of C relative B. So the previous R of C relative B, we had what? This plus this. So 0.4575 I 0.457 0.4575 I plus 0.720. Okay, G. And omega BC, now previous, what is omega? We had 0.166. What else? V of C relative B, that was 0.25 cos 75 I. I'm coming. So tan inverse of 1 point. Oh, see, I nearly made a mistake again. There's 1.720, right? So 1.720. I want to find the angle again. So tan inverse 1.720 out of 0.4575. All right, so that is 75.10. All right, so the angle is 75.1. Let me see what angle we had earlier. 75.179. Yeah, so that's a little different. So this one is going to be called 75.1 I plus sine 75.1 J. All right, so I believe you all get this, the previous. So we said the translational velocity is along this direction. The translational velocity was along this direction, which we modeled it here, and then we found the angle here, which was 75. So the velocity in component to be this and this. All right, so we needed to find the angle theta, and the angle was what? 75. So we put 75 here, put 75 here. All right, then we find the component. I think we did that down here. So V of C relative B was what? 0.25 cos of the angle and then sine of the angle, and we had these expressions, but we didn't even simplify here. So we had this expression. All right, so let's get along. And then so we know V of C relative B. What else don't we know? Omega we know, R of C relative we know. So from here we can just go ahead to start work. So acceleration of C will be equal to, so we have 0 plus then alpha BC K cross 0.4575 I plus 1.720 J, then plus 2 times omega 0.166 K cross the velocity. So if you expand this, you have 0.25 cos 75.1, 0.25 cos 75.1. So you have 0.642 0.642I plus 0.241. So plus 0.241, 0.241, right? G. And then what else? Minus 0.166 squared into bracket 0.4575I plus 1.720 G. So AC will be equal to, so if you cross this, we have 0.4575 alpha BC, K cross I is J, and then K cross J is negative I, so negative 1.720 alpha BC I. Go down with the first guy. So here you have 2 times this, so plus 2 times 0.166 times 0.642, and then K cross I J, and then plus into brackets 2 times 0.166 times 0.24 K cross J negative what I, and minus, so minus 0.166 squared times 0.4575I minus 0.166 squared into bracket 1.720J. So AC, we have 0.4575 alpha BCJ minus 1.720 alpha BCI plus the whole expression here, 2 times 0.166 times 0.642. Is it 0.642 or 0.0642? Come in. Let's verify something. The positions, the velocity. Okay. All right. So 2 times this, we have plus 0.213 I G, and then minus, right? Minus this one. So this 0.2524. So this gives us 0.0797 I, and then 0.166 squared times 0.4575. So we have minus 0.0126 I minus 1.720. So minus 0.0474. All right, so this is acceleration C. So we can group them, the I and the J's. So AC, the I, we have I here, we have another I here. So negative 1.720 alpha BC, and the next I. So this is J, right? So this, and then the next I minus 0.0797, and the next I minus 0.0474. 0, 1, 2, 6 all I plus 0.45 0.4575 alpha BC, and then the next J plus 0.213, the next J minus 0.0474 J. Alright, so AC will be minus 1.720 alpha BC minus 0.0797 minus 0.0126, so minus 0.0923 I plus 0.4575 alpha BC, 0.213 minus 0.0474, so that will be plus 0.16166 G. So let's say equation 1. All right, so that's comparing find acceleration of C when you compare to what B, and I'm going to find acceleration of C when you compare to A. So let's just do it. So we're saying VAC is equal to what? AA plus AC relative A plus alpha AC cross R of C relative A plus 2 omega cross B of C relative A minus omega squared R of C relative A. There is no acceleration at A, that is 0. There is no translation relative velocity at A, that is 0. There is no translation velocity, that's also 0. So AC will be equal to alpha AC cross R of C relative A minus omega squared R of C relative A. So alpha AC we don't know, but you know it's going to be on the K axis or the Z axis, so the direction is K. R of C relative A, R of C relative A. All right, so that was 3 cos 35, then 3 sin 35. So, and then omega AC, what did we get? Omega AC, we got 0.129. All right, so next, so AC will be alpha AC K cross 0.3 cos 35 I plus 0.3 sin 35 J sin 35 J, and then minus 0 point, so the previous we had omega AC to be 0.129. So we have next, so omega AC 0.129 squared. Let me bring that down. So minus 0.129 squared multiplying R of C relative A, which is 0.3 cos 35 plus 0. So I, right, 0.3 sin 35 J. Okay, so from here AC will be equal to, so 0.3 cos 35. What was that? 0.3 cos 35, 0.2457. So that gives us 0.2457 alpha AC, and then K cross I, that is J. Next, 0.3 sine 35, 0.1721. So plus 0.1721 alpha AC. K cross J is what? Negative I. Then we have minus 0.129 squared times 0.3 sine 35 from cos 35. So this is this. I think this is also that. So we have minus 0.129 square times 0.2457. 0.2457. So 0.0041 I minus, and then this time you multiply to 0.1721. That is 0.00286 G. Okay, so you group them into I and J components, right? So that will give us I component minus 0.1721 alpha AC. The next I minus 0.0041 all into brackets I, right? And then plus into bracket the J, 0.2457 alpha AC minus 0.00286 G. So since we are saying the as tangential acceleration, the acceleration at C when it's rotating is the same when compared to A and the same when compared to C, you can equate these two equations. So that will mean minus 0.1721 alpha AC minus 0.0041 I plus 0.2457 alpha AC minus 0.00286 or G is equal to minus 1.72 alpha BC minus 0.0923 I plus 0.4575 alpha BC plus 0.166 G. All right, so we are saying the I on the left is equal to the I on the right. So we say minus 0.1721 alpha AC minus 0.0041 is equal to minus 1.721 alpha BC 72, right? 72, just 72. Okay, this is 72 alpha BC minus 0.0923, and then 0.2457 alpha AC minus 0.00286 is equal to 0.4575 alpha BC plus 0.166. Okay, so from here I think we just group the constant one side, bring the variables other. So question one, I can have 0.1 0.1721 alpha BC plus 1.72 alpha AC. 1.72 alpha BC is equal to this plus this, so that'll be minus 0.0923 plus 0.0041. So that's just minus 0.0882, and then this one we can have 0.2457 alpha BC alpha AC. Why do I keep doing alpha AC? And this one coming minus 0.4575 alpha BC equals, so this will come to add to this, so we have 0.166 plus 0.00286. That is 1.0.16883. So equation 1 and equation 2. So we give that to the calculator to do that, unless you're a magician. But you want to waste your time, obviously. So yes, we are making alpha AC as our X, alpha BC as our Y. So we have alpha AC to be 0.072 and alpha BC to be 0.0215. So rad per second squared, rad per second. Okay, so yes, if you've made it up to this point, congratulations. Yes, if this video is helpful, don't forget to like the video. That's the only way I can see that you enjoy the session. All right, and if you've not subscribed up to this point, also Mr. hit on the subscribe button and subscribe to this channel. Thank you, and wait for the next video.